Hey, good day. This is Mr. Hotchkiss. I am here to kind of go over the assignment that's coming up called the AlkaSeltzer rockets, also known as film case rockets. So right now you can see that I have just put on the PowerPoint presentation that I have offered in class. Um, let's see, I'm going to use I don't know if I can use the pen. Anyway, so I'm going to move on. So here's the title, and I just want you to notice this picture right here. This is a picture of an AlkaSeltzer tablet. AlkaSeltzer tablets look kind of like they come in a packet that looks kind of like this. See that? And inside there is a couple of tablets. You're going to be using those tablets. You can see I have a broken one here, so there's a piece of one right there. Once they're exposed to the air, they start acting up and reacting, so you have to kind of keep them closed. So anyway, so you're going to be using these AlkaSeltzer tablets to create a small rocket out of a film case. The film case looks like this right here. So there's your film case. All right, so we'll get to that in a few minutes. All right, so I know that there's a Disney project going on right now. So this is not Disney, but it's still pretty interesting. So these AlkaSeltzer rockets bring us into a problem. Can simple materials like this and water be used to solve a problem? And our goal is using only supplies provided. Can you launch a projectile into the basketball hoop? And the basketball hoop is, hang on one second, this right here. Here's the basketball hoop. It's going to be hanging from one of our whiteboards on wheels, and you have to try to aim and shoot it. So what can you do using simple materials to create the AlkaSeltzer rocket? Okay. All right, so the competencies that we are looking at today, I'm going to move this out of the way. We are going to be designing a solution to a complex real-world problem by breaking it down into smaller, more amenable problems that can be solved through engineering. So what your job is to create, first of all, an understanding of how this works. Then the second thing is you're going to have to try to engineer some type of a rocket of some sort. And then your next problem is to try to get it to go through the basket. So there's three things you're trying to work at for designing a solution to a complex real-world problem. Then you're going to develop some models to predict and show relationships between variables. So you're going to do stuff to this after you get it all set up to allow it to go where you want it to go. So that's going to be developing models and trying to predict where it goes. Excuse me. So the next thing is you're going to apply the scientific questioning when designing experiments, including stages, variables, data collection, and control. So there will be some data collected. You're going to apply those questions that you saw up here. Can a simple materials be used to solve a problem? Excuse me, sorry. All right, so there are some pre-lab questions, and those pre-lab questions are going to be on this worksheet right here. Let's take a look. There's that worksheet. It's the AlkaSeltzer Rocket Lab page. All right, so the first three questions, you'll notice the third question on my screen up here says to leave this one blank. And that's because you don't have a copy of this on Empower. I was going to have this on Empower, but I decided not to. All right, so let's take a look at number one. What is an AlkaSeltzer rocket, aka film case rocket? I think I've kind of gone over what that is. What you're going to do is you're going to take AlkaSeltzer. You're going to put it inside this film case, okay? Now, I don't know if you know what these are. These are 35 millimeter film cases. These film cases have been around for as long as I've been alive, which is a long time. And what they used to hold is a little, let's say a cylinder of film that had a little piece that came out that you would kind of feed into one of the parts of your camera that would advance the film forward. So that film would wrap around another spindle, and then it would get to a point where you ran out, and then you would wind it all back up, back inside the case, take this whole thing to the Walmart film center and drop it off. And then these cases became kind of like garbage, or they were recycled until teachers came up with ways to use them. So here is one thing about that that's kind of a neat story. All right, so what the idea here then is to take a little bit of water, and I'm not going to tell you how much, that's part of the experimentation, and some of an AlkaSeltzer tablet. And you're going to have choices on how much of that tablet you're going to use. And then you're going to put them both together inside here. You're going to put the cap on, you're going to shake it up, and you're going to set it down on the ground. And you're going to walk back away from it because it will eventually build up pressure inside here and shoot this cap just like that. It'll kind of explode. All right. So let me grab those things I just threw on the floor. All right. So that's what it is. Basically, it's a pressurized chemical reaction. There we go. I'm trying to think of the word. Reaction that's happening inside of this film case. All right. How does it work? That is a question that I'm going to spend a little bit more time on towards the end. I'm going to do some videotaping using the worksheet so you can see that. So I'll stitch that in. And then I'll let you know that we're doing number 2 right now. All right. So that's how does it work? And that'll be the actual chemical equations that are going on. You can see that I have some notes right here that I'm going to go over with you when I get a chance. Okay. And that's what's going to be on this page eventually. All right. So in the official science bin, so you're going to have a science bin and it has the materials that are in it. Those are the white bins that I usually have sitting there where I have all of your equipment in it. Should be 3 pairs of scissors, a glue stick. That's a twisty glue stick. One of these types of glue sticks right here. Okay. You're going to have a hot glue gun, and there should be 2 glue sticks. One might already be in the glue gun, and then there'll be 3 rulers in there as well. There's a couple of other things that are going to be in there. Those are usable things, so that's this film case. There'll be one of those in there, and then there'll be some cards of cardstock, little pieces of cardstock that you can use. There's also 3 copies of graph paper, and that graph paper is to be used for the drawings, which you can see down here at the bottom. It says at the end of class, you will need to turn in the graph paper with your drawings of the rocket parts. That would be things like fins, nose cones, whatever you're adding to this. And then also you're going to turn in your group's film case rocket. I'm going to encourage you to have a name on it, or bring this and your graph paper and your worksheet, that's this worksheet here, all together as a stack, and then I can keep them all together on a table in my classroom. Okay, so some considerations before you move on. The aerodynamics. This thing's got to move up. Now, there's a video out there that I'm going to have available for you that shows Mr. Paddock and I doing this experiment, and we did no modifications to this at all. So when it launched, it went up in the air, but we can't really control it because there was nothing on this. So it kind of spun in the air like this and kind of went wherever it wanted to, and then it hit the ground. So aerodynamics is going to be the key to actually getting it through the basket. The weight, I put on here, to glue or not to glue. That is the question. And the question is actually a good one. Different types of glue are going to have different weights. They're also going to have different aerodynamics. And also the more stuff you put on here is going to make it more massive or more weight. And so it's therefore not going to maybe go as high as you want or be as controllable as you want. So I think that's something to consider. Fins or no fins. Again, I told you what happened with Mr. Paddock and I when we worked on it. So what's going to happen if you put fins on it or if not fins? And I'm going to give you the option to think if there's any other thoughts, any other things. One thing I'm going to say, though, definitely is do not put holes in this container. It will not help it to move forward. In fact, it will release the pressure too quickly and it won't work at all. So no holes. So as far as the whole thing is concerned, there should be nothing changed on the case itself. But putting things on the outside of the case, will that help? That's up to you to decide. All right, let's get started. Don't forget, today you're going to be turning in that worksheet. You're also going to be turning in whatever drawings you have, so the worksheet and the drawing. All you need on the worksheet done are questions number 1 and 2. This should have any drawings or modifications that you're going to be adding to it. So, for example, you cut out some fins to put on the back of it. You need to draw those onto here. Okay, so you cut them out, maybe set them on here and trace them before you glue them on. I think that's about it. And like I said, there will be another video where I will be explaining number 2, and I will get that up and running as soon as I can. It'll probably be at the end of this one. Okay, cool. Good luck.